is up, YouTube? Welcome to the second part of Leetcode SQL 50 solutions. In this part, we'll be covering 5 questions on basic joins. So, as you can see on the screen, these are the prerequisites you should be familiar about: inner joins, left joins, right joins, outer joins, cross joins, and self joins, more or less. But more importantly, what you should definitely be able to recognize is inner joins and left joins. These will help you solve most of the problems. And then there are different types of keys in databases, but yep, we'll get to that when we solve the problem. So without wasting any more time, let's get right into it. The first question: replace employee ID with a unique identifier. So we have two tables. The first one is called employees with the column names ID and name. ID is the primary key, column with the unique values for this table. Each row for this table contains the ID and the name of an employee in a company. Then we have the second table called employee uni, which has ID and a unique ID. ID unique ID is a primary key combination of columns with unique values for this table. Each row of this table contains the ID and the corresponding unique ID of an employee in the company. So these are our two tables, and we'll have to mix and match these to get to a solution. Let's see our problem statement. Write a solution to show the unique ID of each user, which will be coming from this particular table. If a user does not have a unique ID, replace just show null. So whenever we see any kind of an indication that nulls are allowed, or we are taking one table as the master table, we ought to always think in the direction of a left join, with the master table being towards the left side of the join. That's how we'll proceed as well in this example. But let's see the example to make it more clear. So we have this employees table. You can see these unique IDs and names to them. Then employee uni is a table with 3 IDs and 3 unique IDs. And in the output, we can see that all the names are getting populated: Alice, Bob, Mayor, Winston, Jonathan. And nulls are getting populated in case a unique ID was not corresponding in the employee uni table. So for Alice and Bob, which is the ID 1 and 7, we do not have an ID over here, hence nulls got populated. But for the remaining ones, 11, 90 and 3, we did have some unique IDs and those got populated. So let's get on to writing the code to get the solution. First of all, I'll select these two columns. In my result, select unique ID, name, separating these with a comma. Now, as I said, my base table should be towards the left of the join, which is the employees table. So in my from clause, I'll first select employees. Now, since we are using two tables and it's cumbersome to write them again and again, let me give this an alias. And I can directly give this an alias by writing anything in front of the name of the table. So for this example, let me take it as A, for example. And I'll do a left join with the second table, which is employees uni. Copy this, give this an alias B, and give the joining condition, which is given by on. So the common thing between these two tables is the joining condition, in this case the ID. A.id equals B.id. But now what is being picked is to be also named in the select statement. So we are picking the unique IDs from employee uni table. So I can call it as B dot unique ID and give it an alias just to make it look pretty. And name is coming from the first table, so B dot name. Alright, we have selected it correctly and the left join seems correct. Let me give this a run. It's accepted. Let me submit this. And it's accepted. Moving to the next question. Product sales analysis 1. Alright, again we have two tables. The first one is called sales with these columns: sale ID, product ID, year, quantity, price. Sale ID comma year is the primary key combination of the columns with unique values of this table. Product ID is a foreign key. So foreign keys, or primary keys, these can be referred to as the places where we join the tables. That's how you should always look around these questions. So this is a foreign key to the product table. Then each row of the table shows a sale of a product ID in a certain year. Cool. Note that price is per unit, right? Then the second table is called product with simply a product ID. Again, product ID is the common part between these two tables, and a product name to it. Product ID is the primary key for this table, column with unique values of this table, and each row of this table indicates the product name of each product. Alright, we have understood what our two tables are. Now let's look at the problem statement at hand. Write a solution to report product name, year, and price for each sale ID in the sales table. Again, for each sale ID in the sales table, this somehow indicates to us that if we join these two tables, sales has to be kept on the left hand side, and we have to select the entries from the sales regardless of anything else. So this somehow gives us a clue on what kind of a join we'll be using. Return the resulting table in any order. The result formatting is in the following example. Let's see an example. So this is a sales table. There are three unique sales ID. There are some product IDs. There are some years, quantities, and prices. In the product table, we have the product ID to map them. Then the product name, and in the output, we are getting product name, the year, and the price. So this is the explanation for each of those. Need not to go into these because we know how we are going to proceed. This will be a base table, and as similar to the previous one, we'll do a left join. So let's get directly onto the code. So I'll write it like this: select product name. Let me first take all the columns that I need in my output. Okay, as you can see, again this has turned yellow because year is a function, so I'll put it inside backticks so that a column is considered. Finally, price. So these are our three columns. Now using from, our left hand side table should be sales. Let me give it an alias of S. Now again we'll be doing a left join. I'll be doing a left join on product, which is our second table. Let me give it an alias P on S dot. The common link between these two tables is the product ID. S dot product ID equals P dot product ID. That is a joining condition. And I think that should be it. We should get our results, but let's beautify this a bit by giving these aliases and writing the right place where these are referred from. So product name is coming from the product table, so let me write it as P dot product name. For year, I should take it from S. For price, again from sales. Again, this is not compulsory, but it just makes the code better. I'll run this. Alright, cool. It's tested correctly. Let's submit it and move to the next one. Awesome. Coming to the third question of the day. Customer who visited but did not make any transactions. Okay, we have two tables here. First one is called visits with visit ID and customer ID. Visit ID is a column with unique values for this table. Okay, so this is the unique ID for visits. This table contains information about the customers who visited the mall. Alright, we're talking about some mall. Then let's look at the transactions table. We have transaction ID, visit ID, and amount. Transaction ID is the column with unique values for this table. This table contains information about transactions made during the visit ID. So during a visit, the information about transactions is stored in the transactions table. Alright, let's go to our problem statement. Write a solution to find the IDs of the users who visited without making any transactions, and the number of times they made these types of visits. So this is kind of confusing. First of all, to make things clear, let me look at the output. Yep, we are getting a customer ID, although it says over here write a solution to find IDs of the users. Essentially, we want to fetch the customer ID who have made a visit but have not made a transaction. And we also want to give the number of times. So whenever we want to give the number of times anyone has done anything, we use the count function of SQL, and this is used a lot in SQL. So this question will definitely use the count function of SQL, and most probably a count star. Right, return the result table sorted in any order. Let's see the example and try to figure out the solution. We have these visits. These are some 8 unique visit IDs. These are the customer IDs. I can see some duplicates. 54 is happening 3 times. Then the other ones are unique. Then transactions have some unique transaction IDs. Visit IDs are coming common from visit IDs on the previous table, and some amounts are populated. And in the output, we are getting some customer IDs. Let's look at them. Let's look at the outputs that got counted. So 54 has come up with a count of transactions as 2. Let's try to figure out what's happening. 54 is happening, like, is present in visits 3 times, and the corresponding visit ID are 5, 7 and 8. And in the transaction tables we do have 5, but we don't have 7 and 8, and that's getting counted over here. That's why 2 is coming up. Now let's look at 30 in a similar way. So 30 has a visit ID of 4, and so this guy did visit but did not make a transaction. As we can see, for the visit ID 4 we do not have any transaction ID. Right, and the last one is for customer ID 96 with the visit ID 6. Again, this visit ID is absent in transactions, hence you can conclude that this customer did visit the mall but did not make any transaction. So that's how we want the answer. Okay, cool. So these are our 2 tables. Let's move towards the solution, and let's first think about the approach of solving this. So rather than counting transaction as the name suggests, we would rather find out how many times someone visited but did not make a transaction. That's what this column essentially means. So let me write these 2 down first. Select the name of our columns that we want. We'll figure out how to define this particular number count of transactions, but it definitely does not mean the number of transactions. It is actually the other way around, the number of visits where transactions were not made. So just writing this down, and let me think what kind of a join we'll be using over here. Alright, so first of all, let me take one of the tables from, let's pick the visits table and give it an alias of v. Okay, so this, since we want the number of visits where no transactions are made, we'll consider a left join with visits being on the left. So doing a left join on our transactions table, let's name it T, on the common link, which is visit ID. Right, our joining condition looks good, but now we'll have to give a filter and identify how to calculate this. So rather than going along the way of putting a filter of the kind that, hey, this person must have visited but might not have made a transaction, this can be thought in an opposite direction, that there are no transaction IDs corresponding to a visit ID. And in SQL, we can simply write it as where we're talking about transaction IDs are simply absent. So T dot transaction ID is null. That will be my approach. But again, now thinking about how to define count of transactions, we'll simply do a count star from visits in such of a case. So let me, first of all, customer ID is also coming from visits table, so let me write it as v dot customer ID. Clean it up a bit. v dot customer ID as customer ID. and select, or not select, because select has been already been used, count star from the visits table. This should figure this out, but alright, one thing that got missed is we want to tell the number of transactions corresponding to each of the customer. So if I don't group the results by customer ID, I would have gotten a result like 54.1, 54.1, 31, 96.1. So I must group them by customer ID. So a group by, this will ensure a distinct number of customers and their corresponding count number of transactions. Right, group by. I think our query is complete. Let's try it out. Awesome, let's submit it. We're done with this question. Quite a good question, I'd say. Moving to the next one. Rising temperature. Right, we have a table called weather with the columns ID, record date, temperature. ID is the column with unique values for this table. There are no rows with the same record date. This table contains information about temperature on a certain day. Write a solution to find all dates ID with higher temperature compared to its previous dates yesterday. Okay, so we want to essentially find out IDs. That will be our output. Yep, looks correct. And it can be in any order, and we can see the example. So let's have a look at the example. This is our weather table. We have the unique IDs 1, 2, 3, 4. Dates are 1st of January, 2nd, 3rd, and 4th of January. But these temperatures, our output are 2 and 4. Why 2 and 4? Because on 2nd, the temperature 25 is greater than 10. And on 4th, the temperature 30 is greater than 20. So 3 and 1 are not selected, and 2 and 4 got selected. So to get an approach of this question, we have to think it in a way that we only have a single table, but we want to compare it with the previous rate in consideration. Hence, we will have to join this table with itself and give it two different aliases. So consider like a duplicate of this table happening like just in parallel to it, and we are joining this date with the next date. That's how we'll do the join. And also will, in the joining condition, we'll also put the condition that hey, the temperature of the second table in consideration should be greater than the temperature in the first table in consideration, which are essentially the same source tables. Okay, so let me start this by writing the columns to be selected, which is simply ID. Select ID. Alright, so let me, for this example's sake, think that the second table, the duplicate of the second table, is where I am picking things from. And since it's called weather, let me call it weather2 or W2. I'll name it later on, but yes, moving ahead, selecting this from. So let me put the first table's name, and I'll simply do an inner join in this case because I don't want duplicates or any table being a superset of the different table. I want to just find the intersection of that particular points, those data points where we are getting these conditions satisfied. Hence, the type of join used will be an inner join. So let me write the name of the entire table, weather, and give it an alias w1. Since I want an intersection in just the relevant ones, I'll do an inner join with the same table, but naming it w2 or weather2. Now the joining condition on, this is where we actually use our brains to identify this condition that hey, the date from the first table and the second table's next date should match. So for this, I can't directly do this for dates. If it would have been IDs or numbers, I could have used a +1 or something like that, or greater than sign. But for dates, since I need to check the very next date, I'll have to use the date add function. So to write this down, I'll write it as date add. What am I adding the date to? To the first table's record date, W1's record date. I'll add one single day. So the syntax for that is interval 1 day. So this part ensures that an interval of 1 day is added to the first table in considerations record date, and that should be equal to the second table's record date. So w2 dot record date, that will be our joining condition, and the second joining condition will be the temperature condition, which is the second table's whether the temperature should be greater than the first table's temperature. So w2 dot pick up temperature is greater than first table's temperature. I think this looks good. All I need to do is clean this up a bit. I'll put the exact column over here, which is ID, and try to run this query and see if it works. Looks like it got accepted. We submit this. Alright, cool. So this was kind of a good question because we are using the same table and joining it with itself on some differing dates and a different temperature. Quite a good question. Moving to the next one. Average time of processing per machine. Again, we have a single table and a very big description of it as well. Let's go through it. The name of the table is called activity. The column name is machine ID, process ID, activity type, and timestamp. Okay, timestamp is a floating type of a number. That's interesting. Let's move ahead. The table shows the user activities for a factory website, machine ID, process ID, and activity type. Okay, so we're talking about a machine doing some kind of processes, and there are types of activities, and it's taking some time to do it. Right, machine ID is the ID of the machine, process ID is the ID of the process running on the machine. Cool, with the ID machine ID. Activity type is an enum. Okay, activity type can be of only two types, which is start or end. That's interesting. Then timestamp is a float representing the current time in seconds. Alright, that's why it's a float type. Then we have start means a machine starts and the process at a given timestamp, and end means the machine ends the process at the given timestamp. Quite intuitive. Moving ahead, the start timestamp will always be before the end timestamp, which makes sense. Start should always be before the ending, but that has been clarified to us in the question. We won't have any kind of an edge cases over here for every machine ID and process ID pair. Alright, so for each machine and a process, when the process is happening, the start time will be lesser than the end time. That makes sense. It is guaranteed that each machine ID process ID pair has a start and end timestamp. So this is quite good information to us that every process that starts will end. Alright, let's look at the problem statement. There is a factory website with several machines running the same number of processes. Write a solution to find the average time each machine takes to complete a process. Alright, average, will probably be using the average SQL function to do this, and same number of processes are being conducted across machines. That is information that is given to us. Right, let's see how we find it useful. The most useful part that I can find right now is that every process that starts will definitely end, and for each machine the number of processes are same, whether it may be 3 processes per machine ID or 2 processes per machine ID, and so on. So that is good, and we can kind of imagine this table breaking down into two tables, where one of the tables will only have the start times and the other table will only have the end times, and all the other timestamps and processes and machine IDs will be populated accordingly. That's how I'm kind of trying to visualize the structure of the table. But let's see. And we need to find the average time, right? Time taken to complete a process is the end timestamp minus start timestamp. Alright, since we don't have a actual timestamp kind of a value, we can do a simple subtraction to find this value, so that we can subtract them and find out the averages. Alright, the average time is calculated by the total time to complete every process, so all the processes must be taken into consideration. Whenever this happens, we need to move towards the direction of thinking along the lines that we need to group every machine ID and every process ID, group by like on both of these levels. then only we'll get the correct answer. Because the first intuition is we can average out on a machine level, but we also need to average out on processes level, right? This gives us a good information. The resulting table should have machine ID along with the average time as processing time. This is the alias name that we want. We don't want the process time in the final solution, but we do want it to do the average on. Cool. And this should be rounded to 3 decimal places. We'll also use the round function of SQL for 3 decimal places. Return the result table in any order. The result format is in the following example. Let's see. Okay, machine ID 0 is running for process 0. We have a starting time. Again, for the same combination, we have an ending time. And then process ID 1 for machine 0, again start and end sometimes are given. For machine number 1, again there are 4 entries, process number 0 and 1 are running. Similarly for machine number 2, we're getting all these start end times, and the output has a machine ID and a processing time. Let's see how it is getting calculated in the explanation. Machine 0's average time is, okay, we subtracted this number and this number, and we also subtracted this number and this number, added them up and divided them by 2. That is averaging things out. But we cannot directly use the divided by 2 formula, because we can't be sure that always a 2 is happening. Hence an average function of SQL will help us out, right? And similarly a calculation is done for machine 2, so average. Okay, this sounds like quite a problem. Now that we have understood it, let's move towards the solution. First, let me write down the names of the columns to be selected. Machine ID, and processing time. Again, we have a single table, and as my intuition was going, I can divide this activity table into 2 parts, one having just the activity type of start and the other one just having the activity type of end. So I'll do a from over here, from the name of the table, which is activity, and let me give this first table the alias a1, where I'll only consider start. I'll define this later on during my joining condition, but for now I've written it like this. And again, I only want the common things to be happening, so what I need is an inner join over here as well. Inner join. I don't need a superset or a subset, anything like that. Inner join, same table, e2. Cool, we do have this now. Let me pick up the first machine's machine ID, because it's fine to take either of them. I'm just taking the first one for this and give it an alias as machine ID. And over here we'll have something around the lines of an average happening, an average function of SQL happening, and which will be rounded off to a round function happening. And I think it was up to, yes, 3 decimal places. Closing this back bracket out. What do we need to average from both of the tables? The ending time of the second table minus the starting time of the first table. That was our calculation. So I'll fill this up, but let me first join these tables. That will be the first step, joining these 2 tables. A1 dot, we need to join on both the grains. As I said, I want to average on both the grains, so the joining condition will also have both the grains. A1 dot machine ID. Machine ID should be same in both of the tables. A2 dot machine ID and A1 dot process ID, because our calculation must be done on process level as well. A2 dot process ID looks good to me. Now let me have the where conditions popping up, where I identify that the A2 table is the ending table and the A1 table is the starting table. That can be simply done as where A1 dot activity type equals start, and A2 dot activity type equals end. You see how we have like distributed the same table into two parts by giving them some conditions of start and end. Again, just to get the final answer, we'll need to group them by machine IDs because we want a single answer to a single machine. So finishing this query off with group by e1 dot machine ID. Let's pick it from here. And now to do the average, as we know, we need to subtract the timestamp. So for that, it will be an ending timestamp minus the starting timestamp, and ending is coming from a2. So a2 dot timestamp. Again, you can see that timestamp has turned yellow because it is a SQL keyword. I need to put it inside backticks so that a column is considered. a2 dot timestamp minus a1 dot timestamp. Put it inside backticks again. Alright, we are picking up machine IDs from any of the tables. A2 could have worked over here as well. We're doing a rounding, an average, A2's timestamp minus A1's timestamp, considering we are picking the same machine ID and the same process ID. At a point, rounding it off for 3 digits. We'll need, for alias, we'll put in as processing time from activity 1 and join activity 2. Doing these joins where A1 will have the activity type of start, A2 will have an activity type of end, and we'll group it by machine ID. Looks good. Let's give it a shot. Alright, got accepted. Let's submit this. Right, our answer got submitted. Thank you so much for watching and stay tuned for the next video and give this a shot and good luck for your presentation.